Alright, now let us look at this problem on the general probability. And we know that B and H are two events. The probability of B occurring is equal to 0.7, and the probability of H occurring is equal to 0.5. And now we want to determine whether these two events B and H are disjoint or not. So remember, if the two events, say B and H, are disjoint, then that means the probability of B or H is equal to the sum of probability of B occurring and the probability of H occurring. So now, because we know the probabilities of B and H, so we can plug in the numbers. That means PB is equal to 0.7 and PH is equal to 0.5. And we got the sum is 1.2. That means if the events B and H are disjoint, then the probability of B or H occurring is equal to 1.2, which is a number greater than 1. And we know that the probability can never be a number greater than 1. That means this probability is not 1.2. And thus, we can know that the events B and H are not disjoint. So we can write down our conclusion here that they are not disjoint. Alright, now let us look at the second part of this problem. And we know that the probability of either H or B occurring is equal to 0.3. That means the probability of B or H is equal to 0.3. And then we want to know what is the probability of both B and H occurring. So remember, we have the general formula for the probability addition. That is P, R, B, or H is equal to the probability of B plus the probability of H minus the probability of B and H. That means both two events will occur. Alright, now let us plug in the numbers. We know that the probability of either H or B occurring is equal to 0.3. That means this part is equal to 0.3. So 0.3 on the left hand side. And then the probability of B occurring from the given condition, we know it is 0.7. And the probability of H occurring from the problem, we know it is equal to 0.5. So plus 0.5. And we want to find the probability of both B and H occurring. So minus probability of B and H, which is the number we want to find. Alright, now let us solve this equation. That means PR B and H is equal to 0.7 plus 0.5 minus 0.3. And if we do the algebra, it is 0.9. Alright, after we find the probability of both B and H occurring, and then we want to see under this setting whether B and H are independent or not. Okay, so remember, if B and H are independent, that means the probability of B and H is equal to the product of the probability of B and the probability of H. So now let us plug in the numbers. So in this setting, we find that the probability of both B and H occurring is equal to 0.9. Okay, so that means the left-hand side is equal to 0.9. And from the given condition, we know that PB is equal to, let us see, 0.7. And the probability of H occurring is equal to 0.5, and their product is equal to 0.35. Of course, we know that 0.9 cannot be equal to 0.35. So we conclude that B and H are not independent. Okay. All right. Now let us look at the third part of this problem. Now, if we assume that B and H are independent, and then we know that this means the probability of both B and H occurring B and H, not B both H. So the probability of B and H is equal to the probability of B times the probability of H. And plug in the numbers, we will know this is equal to 0.5 times 0.7, and this is equal to 0.5. So the probability of both B and H occurring is equal to 0.35. All right, now again in this setting, we want to know that the probability of B occurring given H occurring. So this is a conditional probability. We want to find in some mathematical expression, we know that we want to find the probability of B given that H occurs. But because B and H are independent in this setting, we know that PB given H is equal to PB. So we know that PB and PB given H is equal to 0.5.